All right, so today I'm going to show you how to reflect using your compass and straight edge, and I'm going to show you how to translate using your compass and straight edge. We do not do rotations with constructions. All right, we do not do rotations. We just do reflections and translations. All right, so let's get this going here. First up, we're going to take point Z and reflect it over line F. So you guys, in your mind right now, don't put it on your paper though. In your mind, think about where Z prime should be, right? Z prime should not be on this side of the line, right? Because I'm flipping it over. Z prime should be somewhere over here on the other side of the line. So the first step here in reflecting a point through a line is draw. We'll construct. I shouldn't say draw. We're going to use our compass here. Construct a perpendicular line through Z. That's our first step. All right, construct a perpendicular line through Z. And we have done this before. I just need a little review. We've done this. This is not a brand new construction. As soon as I do my first step, you're going to be like, all right, I'm good to go. All right, so I need a perpendicular line going through Z that forms a right angle with M. So everyone's going to grab their compass right now. Put that compass point on Z for me. And now you got to play around with your compass opening right now because you need to intersect M. Anybody remember in how many spots? 2. It's going to look like a smile here. It's going to look like a smile. So play around with your compass opening and get it to intersect M in 2 spots. And if you want to label those two, if you want to mark those 2 spots of intersection, go ahead. We have plenty of time today, so I'm going to take this slow to make sure everyone's step by step here. If you are ever doing this on your own and for whatever reason you can only make it intersect the line in 1 spot, remember lines go on forever, so extend your lines if that ever happens to you. Okay, you can only make it intersect in 1 spot. I'm going to make sure we're all in the same step before I move on. Okay, from here now, your compass is opened a certain amount. You can keep it that opening, or you can open it up a little bit more. But we're about to make 2 more arcs. Those 2 arcs have to have the same opening of your compass. Okay, so just remember that. Keep what you have now, open it up a little bit if you need to, but the next 2 arcs we make have to be from the same opening of your compass. Ready? Take your compass, put it on one of the points of intersection. Put it on one of the points of intersection, not point Z anymore. Put it on one of the points of intersection. And you're just going to make an arc ahead of that first one. It has been a while since we've done constructions. Just a reminder, try to make your arcs small, okay? Because you're going to be doing this, might be 3 times on a diagram coming up here. And you don't want 9 arcs just flying over. All right, try to keep them small. All right, once you've done it from one point of intersection, keep that same opening and do it from the other point of intersection. And hopefully your 2 arcs there intersect each other. Okay, put it on one point. Here we go. Come on. Yep, and then make an arc. Okay, now see, here's the problem though. We actually need one that actually stays, because once you make that arc, you can't open or close this. You need to keep it the same opening. Okay. That's why I'm always suggesting sturdy compasses. If you have that point of intersection, take your straight edge, line it up. Draw through your perpendicular line, which was only step 1, right? We're trying to flip Z over M. That was just step one. So go ahead and get that perpendicular line, and then we'll talk about where do I find Z prime. All right, last step. Last step. Copy the distance. And what do I mean by copy the distance? Sydney just asked a question from the quiz to find that line of reflection. And what did we always say? The distance from the point to the line always matches on both sides, right? That distance always matches on both sides. So Z to the line better match Z prime to the line, that distance. Take your compass. You're not going to make any marks here. Measure the distance from Z to where your perpendicular line intersected M. Measure that distance, because that distance has to be the same when we go to Z prime. We're not making any arc marks here. Everyone has it open. Measure that distance. Now, again, it's got to stay the same on the other side of the line, right? So everyone's going to come now. Now move your compass point to that intersection. And make an arc through your perpendicular line. Now mine just coincident, it's just total coincidence that it intersected on the other two. Total coincidence. That won't happen every time. But we want to make sure, again, take a look at my diagram, please. This is congruent to that, wherever we have the prime one. So you found Z prime. So we got to make a perpendicular line, then copy that, make sure the distance stays the same on both sides of the lines. Questions? That's just a point. What if we have to do multiple points on the same one? Anything you want to ask about this one? Because you're going to start trying it out a little bit on your own now as I walk around and help you out. All right, here we go. I want to take this triangle and again, flip it over line M. Reflect it over line M. Ooh, good news. You don't have to do all three. Why not? If K's on line M, it's not going anywhere. So we already know where K prime is going to be. Same place K is, right? Because if it's on the line of reflection, it does not move. All right, I will do one of them with you, and then I'll let you do the other vertices. So I'm going to do J right now, everybody, J. So the first step, make your perpendicular line through J. So put your compass point on J. Play around with your compass a little bit. So it intersects line M in two spots. So this is almost like looking like a sad face here. Okay, so try to play around to intersect M in two spots. Take your time. This one's a tough one because it's a kind of a small distance there. You have to be really skilled with your compass. Mark your 2 points of intersection. And remember, if you don't like that small opening, these next two arcs, you can open up your compass a little wider if you want. For the final two arcs, you can open up your compass a little wider. Go from each point of intersection. Make two arcs that intersect. Take your time, try to make not huge arcs. And then when you're ready, line up J. Line up vertice J with that point of intersection and draw in your perpendicular line. And once you have the line copied, match the distance, right? So I'm going to go from J to M now. I'm going to go J to M. Okay, that's a certain distance away. And then I'm going to make sure that's the same distance on the other side of M. Boom. And there should be J prime. And then now we'll take our time now. I'll come around and we'll help you if you need it with H prime. If you can do H prime on your own, great. Go ahead, connect the 3 vertices and make your reflected triangle. I'm liking the small arcs on many of your papers here. The bigger the arcs, the more confused you get with what belongs with what point, what arc belongs with what point. Good. Once you guys find H prime, make your triangle now. All right, because remember, we're not just flipping the points over, we're flipping the whole triangle over. So once you guys find those points, make your triangle. Whew. Reflections. Questions? All right, so the next one you'll see there will be on the assignment tonight. All right, next. You guys did a great job with the reflections. Now can you find me the line I reflected over? All right, I did 2, I don't even know, boomerang quadrilaterals here, boomerangs, I don't know what these are. And I want to know where's the line here I reflected over. All right, well, a little different of a construction here, but let me take you back to the first one we did when we had Z and Z prime here. This was the line we reflected over, right? Everyone agree? That was the line, line M. I'm trying to find that line right now in this next example. But look at what we just did here, because I want to put a vocabulary term to this. We know these two are congruent to each other, right? And what type of line was this that we make at the beginning? It was perpendicular. What's my line of reflection? It's a blank, blank. Perpendicular, bisector. That's what the line of reflection is. All right, so if you want to make a note here, yeah, I'm asking for the line of reflection, guys, but if I wrote this another way, I'm also asking for the perpendicular bisector. That's what the line of reflection is. It's always a perpendicular bisector. So you guys have a choice right now. Please connect a pre-image and an image point right now. Take your straight edge, connect them, make a segment. A to A prime, B to B prime, C to C prime, doesn't matter. It's going to work anywhere. Now all I need to construct, right? Here's that segment you just made. Now I need your help constructing a perpendicular bisector, which we have already this year. Just need a little reminder. It's not the same as the smile and two arcs below it. Everyone put your compass point on one of the endpoints. You guys remember this one. This is probably the one we use the most. And take my compass and open it. Open it. More than half the length. Good. So take your compass right now. Open it up to more than half the length of your segment you're about to bisect. And this is probably the biggest arc we make of any construction. You want to make about a half circle size arc. Okay, half circle sized arc. Make sure it goes past the halfway point of your segment. You want to keep your compass opening the same and travel over to the other point, the other end point. So you have it on one end point, travel over to the other end point, but please make sure you are on the same opening as the first. Anybody remember how many points of intersection do we want on this one? Usually one does the trick. Yeah, we need two here to line up our straight edge. 1, 2. You need 2 points there. And then, yep, grab your straight edge, and you have yourself a line of reflection. Draw your line in. Let's go. Draw your line in. Draw your line in. The construction marks alone don't cut it. And then a question I always get on this one from students is, do we have to do it again on another set of points? And the answer is no. If you want to, it's going to be like a check. It should, you connect B to B prime now, it should be the same line. Okay, same line. So no, you do not have to do it from another set of points. All right, any issues you want to talk about with the reflections? Because now we got to move on to translations, which is another beast. All right, reflections and finding the line of reflection done. Now let's talk about a translation. Capital T, translation, we're going to take Z. Ooh, look at where we're translating it. Along, anybody remember? I know it's a ray, but in this unit we called it again with a V and an ector. Vector, good job, good job. I had a kid the other day tell me vertex, and I was like, we have more problems than math if you're telling me the answer is vertex there. All right, that's called a vector. So just so everyone knows what we're about to do, we're going to take point Z. We're going to move it in this direction of the vector. So we're coming this way. We're going to move point Z this way, and we're going to move it the length of PQ. So how long PQ is, that's how far we're going to move Z. All right, so let's get in our mind right now where this is going to be. You tell me. Z prime going to end up there? No. Over there? No. Here? No. Here? No, right? It's going to probably be somewhere in this vicinity here. It's got to move this direction, guys. Coming this way, that distance. So make sense what I'm about to do and where Z prime's probably going to be. All right, how do I do it? First thing, let's move it the length of PQ. Everyone take your compass and just measure PQ for me. Take your compass, open it up to the length of PQ. That's the first step, is we're going to move Z the length of PQ. So just open up your compass the length of PQ. No markings needed yet on this. No markings. Just open it up. We're all good. All right, now come down to Z. Put your compass point on Z. And remember, your compass is open up to the length of PQ right now. And what we're going to do is, coming from Z, we're just going to make an arc out in front. That's it. No big deal yet, right? Measured it. So here's what we know right now. And please don't put any points on this arc. Here's what we know right now. Any point on this arc right now is the same distance as PQ to Z here. Right? We have the distance matched now. We just got to figure out which one of these points on this arc goes this direction. Okay, does everyone see what you just did? You have now matched the distance right now. I just got to figure out the direction. All right, how do I figure out the direction? Okay, here's where it gets a little nuts. So I'm going to slow it down. Now, put your compass point on P and put your pencil point on Z. Measure that distance for me. No arcs needed. So I'm going to the beginning of the vector to Z. Beginning of the vector to Z. Once you have that measured, now you're going to put your compass point on the end of the vector. Hey, watch. Everybody watch. Notice how I'm sliding down in the same direction now. I'm matching the direction. So slide it down to the end of the vector and make an arc so it intersected that first one. So this just requires two arcs. The distance and the direction. And remember, we're not making a line segment here. This is it. Z prime. You found it. Whoa. One more time. Because I know we do it together and it's, oh, that's not too bad. But then you do it on your own. You're like, what was that step? Measure the vector. Go to the point. Make an arc. You just took care of the distance. To take care of the direction, you go to the beginning of the vector, to the point. Ready? Slide it down so you go in the same direction. And then boom, there it is. Okay? Think you can do that for a full triangle. You tell me, do you want to do another point together or you want to try all three on your own? Why do I even ask, right? Nobody breathes in this class anyway. We're all good? I'll do one with you. Sure. Let's do point L. I'll move point L with you. So measure vector EN. Measure vector EN. Go to point L. Whoop. And make an arc out in front of point L. And again, make sure you don't put it behind, right? The vector's telling you, hey, we got to go this direction, so don't put any arcs behind it. Next step, now we're going to take care of the direction. I'll let everyone make your arc first. Sorry, I'm going a little fast. Once you get that first arc, now I go to the start of the vector N, and I measure the distance from N to the point I'm translating, which now is L. And now we match the direction. Go down the slide, right? I always say, go down the slide. Go down the slide, match the direction. And there it is, L prime. So go ahead, I'll walk around helping you out if you need it to get P and A where it needs to go. But hey, keep in mind, guys, hey, the vector's going this way, so P and A should be going this way as well when you're done. All right, shouldn't be on other sides of your paper. P and A should be going in this direction.